And we realize that this is made of brass, 101 times 10 to the power 9, right? So this will be equal to 50 power 3 times 0.25 divided by 1.963 power minus 3 divided by 101 power 9. So it's equal to 63.048 times 10 to the power minus 6 meters. Okay, so it's very small. Then we look at section 2. So section 2 now is between point A to point B. Okay, so that is section 2, point A. So if we look at the hangman situation again, okay, so now we want to look at this section now. Okay, we want to look at this section now. A to B. Can anyone tell me A to B can feel what load?
200.
200.
Yeah.
200.
Tension.
Yeah, well done. Okay. It's only able to see the 200. It cannot see the what? 150. Yes. I'm glad you guys are seeing it. Okay. So for next we're going to calculate deflection section 2. So P2 is going to be positive 200 times 10 to the power 3 Newton. So we know that this is going to be tensile or tension. So immediately we know that deflection of now is AB is equal to 200, positive 200 times 10 to the power 3, right? Multiplied by the length of 0.5. The cross-sectional area is 314.159 times 10 to the power minus 6. And then you have 200 times 10 to the power 9 because it's made of steel this time. Okay, so 200 power by 3 times 0.5 divided by 314.159 power minus 6. So it's equal to 1.591 positive. Okay, can you all put up here positive also? My bad. Okay, so positive 592 times 10 to the power minus 3 meters. Okay, and lastly, section 3. So section 3 now is between point B to point C. So we will look at section 3 now, right? So we are looking at the last end. Okay, so we are looking at this end down here. Can anyone tell me what load is it going to feel? Anyone?
200 in
200.
compression.
No, it's not going to feel anything.
Yeah, nothing.
Yeah, this over here, right? It's not going to feel anything anymore.
That's a
Why
good
is
question.
that?
Hey?
Yeah, why is that?
Yeah, so if you look at the hangman theory again, right? If you look at the hangman theory, the load is applied down here. Oh, okay, wait. The load, right? The load is going to apply over here. It's going to apply at his stomach. Okay, it's going to apply at his stomach at 200 times 10 to the power 3. Can the feet feel the load?
Oh no.
Yeah, the feet is not able to feel the load. Yes or no? Hello.
Yes,
You're,
yes.
yeah, does that make sense now, right?
Yes.
So that's why the feet don't feel the 200. That's why this hangman is so important. You can visualize the hangman better than anything else because you feel it. If you can't in your written exam, if you can't feel it, you just hang yourself. Don't do that. Hang your hand on a ceiling or on a hand or on a chin-up bar and try it. Get your kid or get your wife or get your girlfriend to put something on your stomach. Your feet will not hurt at all, for crying out loud. Yes or no? Okay. So I want you to think this way. There's nothing to what? Memorize. All is based on what? Physics. Okay. I want you to or do some very simple experiment. Okay. So from here, yeah, sorry, I was a bit loud down there. My wife always tell me I need some drugs to calm myself down. Okay, but anyway, P3 is equal to 0. Deflection of BC therefore is equal to what? 0. Okay. So the next thing we want to do is find the deflection due to the applied load, or the total deflection. Okay, you're going to find the total deflection due to the applied load. Now you understand what is the applied load, yes or no? Right? So the total deflection due to the applied load, so is delta L is equal to delta AD plus by delta AB plus by delta BC. Right? So you add all of them up. So one is at 63.048 times 10 to the power minus times 10 to the power minus 6, right? Then plus by 1.592 times 10 to the power minus 3. And the total deflection, okay, so it's 63.048 power, 63.048 power minus 6 plus by 1.592 power minus 3. So it's 1.655 times 10 to the power minus 3. Right? So now what we have just done is we allowed the structure, don't hang yourself, is you allowed the structure to move, and the deflection is 1.655 due to the applied load. So from here, right, from here, next we're going to add, okay, the next thing we're going to do is we're going to add a redundant load at point C such that the total deflection such that the total deflection is equal to 0. Okay, you're going to do that now. Okay, so I'm going to draw the structure. I'm going to sketch out the structure again quickly. So this is our structure. It's built in. Right, so now we are going to add a redundant load. So I'm going to show you now. So we have one over here. Right, then we have another long piece. And then finally, we have this piece. Okay. So now we're going to add a redundant load. And this is PR. Okay. And this is the redundant load. Now, so I'm going to label this point A, point D, point A, point B, point C. Okay. And now I'm going to take the whole thing. I'm going to copy. I'm going to go over there. I'm going to do the hangman again. And then we're going to rotate. Oi. Rotate. Right. Okay. Now, first of all, what you realize is all the internal load. Remember when we did earlier for this one, the applied load, we have the what? We have the 150 and we have the what? We have the 200. Okay. So when we put in the redundant load, you don't include the what? You don't include the 150 and you don't include the 200. Are we clear? Okay. So at point A, where the diagram you see now, you don't see the 150. At point B, you don't see the 200. You only see the PR, which is the what? Which is the redundant load. Okay. So you cannot consider the load twice. Basically, that's what I'm telling you. Okay. So when you do the redundant load, you remove all the internal loading. Okay. That's all you have. Now, question. How many sections do you need to divide this structure? 1, 2, or 3? Anyone?
1.
1.
1. So when you divide the structure, you divide the structure based on what? 3 things. Different material, different cross-sectional area, or applied load. So after I make you recall that, how many you divide? Some of you say 2, some of you say 3. The answer is 3. Why? Okay. So over here, this is 1 because it's brass. Over here, you divide because you change in cross-sectional area and you use a different material. And the last one over here is 3. So altogether, you have 3. Okay. So remember what we've written down? Right? Earlier, we written down that we divide the structure into components at either the applied load or the change in cross-sectional area or length or the use of different material. So I'll put down here including length. Okay. So now, coming back to here now, right? So now, if you look at the redundant load, right? If I push the redundant load upwards, right? Can BC feel the redundant load? Yes or no?
Yeah.
Yes.
Yep. Can AB feel the redundant load?
Yes.
Are you very sure? Yes? Yes, right? And can DA feel the redundant load?
Yes.
Yes. Oh, yes. And this is again back to our. That's why when I teach a hangman, what do I teach you, right? I bring it back. I bring you back to here, right? Right. Remember when we have this example, when we have P/2 acting on your feet, what will happen? Right? You told me the hip can feel it, the lower body can feel it, and the upper body can feel it. That's why the person don't die, right? If someone is hanging, you prevent the person from dying. What do? You put forces at the feet, yes or no, right? Push upward
Yes.
so it will not stretch the neck. Am I right?
You're right.
I'm right. Unbelievable. Right. So from here, we know, right? So we're going to form the equation, okay? So we're going to form the equation. So the redundant load, deflection due to the redundant load will be equal to deflection of 1, right? Plus by deflection of 2 plus by deflection of 3. And you realize of how the redundant load is adding is going to be what? It's going to be in compression. Okay, so you form the equation out, right? So you write down P1 minus P1 for section 1 is equal to 0.25 divided by 1.963 times 10 to the power minus 3 times by 101 times, oh, sorry. Then you multiply by 101 times 10 to the power 9. So that's the first one. Plus, again, minus by P2, because everything is under what? Compression, 0.5. Divide by 314